this exercise is fairly simple. It measures your understanding of the matrix as a linear map, or maybe you just know the rule and know how to apply it, but okay, then maybe it doesn't test your knowledge of the matrix as a linear map. But it is very useful to think of this setup as follows, because if you think that the matrix is a linear map, then it takes a vector of length 3 and outputs a vector of length 4. If this is defined, first off, if A is a 3 times 4 matrix, then it has 3 rows and 4 columns. Then A transpose has 4 rows and 3 columns, because you transposed it. Transpose is where you put the columns in the place of the rows, and the rows instead of the columns. It's like this is 3 and this is 4. So you flip it. Kind of. I mean, well, yeah. The rows become columns and the columns become rows. So this is what it means. And this is just... So, yeah. This is this, and then B, if B has dimensions n times m, then clearly as a linear map, it takes a vector of length n as input and outputs a vector of length m. Now, this is a composition of maps. So I apply A transpose to X, I get a 3-dimensional vector. I take in a 3-dimensional vector using the other map, and then I output something, which can be anything. So in order for this to be well defined, n needs to be equal to 3. Otherwise, my output here does not match the input that's in the next map, because we're composing maps by multiplying matrices. Okay, now let's make use of the second fact, which is regarding BA transpose. Why did I write BAT? It's not BAT, it's BA transpose. And BA transpose, A transpose has 4 times 3 as its dimensions. Takes as input a 4-dimensional vector. And B, what B does, it takes in a n-dimensional vector, which we know now is equal to 3, and it outputs an m-dimensional vector. Now, the output should match the input, and that's really the idea of it. So if the output has to match the input, then clearly m needs and must be equal to 3. 4. Yes. Okay, well, maybe it doesn't need to be equal to 3. It needs to be equal to 4. Then the dimensions of B are 3 times 4. This is the only way we can define it properly. Otherwise, it doesn't make any sense. If you have the intuitive conceptual understanding of what a matrix is, then it will greatly assist you. You don't need it for this exercise, it turns out, but I think it is very powerful. But that is just my opinion.